So hello everyone, in this video we will solve GfG problem of the day, and the problem name is sorted subsequence of size 3. So let us read the problem statement. So you are given an array ARR. You need to find any 3 elements in it such that ARR of I is less than ARR of j less than ARR of k, as well as their indexing should also be in strictly increasing order. Then they have given some note, you can read it. And we need to return that triplet if that triplet exists, otherwise we need to return an empty vector. So let us see this first example and try to understand the question and find some solution out of it. So this is the first example that they have given, and what the question is saying that we need to find 3 elements, ARR of I, ARR of j and ARR of k. This should be in strictly increasing order, as well as their indexes I, j, k should be also in increasing order. So from this ARR array we can say that 1, 2 and 3 are in increasing order. So 1, 2, 3 are in increasing order, as well as their index 0, 1 and 4 are also in increasing order. So this is one triplet we can find from this ARR array. So this is what the question is saying. Now how do we find that? So if I am standing at some particular element, let's say I am standing at the jth element. So what we need to do now? So if I am currently at ARR of j, we need to find any element which is greater than ARR of j from its right side, and we need to find any element which is lesser than ARR of j from its left side. So this element from the left side will be lesser than ARR of j, and this element from the right side will be greater than ARR of j. So if we can find these two such elements, then obviously that left element will be lesser than ARR of j, as well as this ARR of j will be lesser than that element which we find from the right side. So combining these two equations, what we can say, that left element is less than ARR of j, and which is again less than that element that is present on the right side. So this we can do, but how will we do it? So what we can do, we can maintain one prefix array and we can maintain a suffix array. So suffix array will give the suffix array will give the maximum element from this index j plus 1 till the end, and prefix array will give the minimum element from this from 0th index till j minus 1. So sorry, not j plus 1, j minus 1. So prefix array will give the minimum element from 0 till j minus 1, and suffix array will give the maximum element from j plus 1 till n minus 1. So let us dry run this and see how we can get our answer from that. So let me redraw this array 1, 2, 1, 1 and 3. So we will create one prefix array and we will create one suffix array and prefix array. So initially there is nothing to the left, so prefix array's initial value will be 1, and towards its right there is nothing, so suffix last value will be 3 only, or the last element. So we'll start iterating from here. So we will compare what is the minimum element till now. So how we can get the minimum element till now? We can get by writing this prefix of j minus 1. So let's say we are iterating with j. So prefix of j minus 1 will give the minimum element till now. And what is the current element? Current element is ARR of j. So how we can so what we need to do now to fill this prefix of jth position? So we need to get the minimum of both of these. So we will check. So what is the minimum element till now? Minimum element till now is 1. So 1, and what is the current element? Current element is 2. So minimum of 1, 2 is 1. So we'll write 1 here. Then we'll come across this index. So minimum till now is 1 and current element is 1. So minimum will be 1. Again minimum will be 1 only, and in the end 1, 3, what is the minimum? Minimum is 1. So our prefix array would look something like this. So yeah, Now for the suffix array, we will start iterating from the back because we need element from j plus 1 till n minus 1. So we need to iterate from the back for that. So 1, 2, 1, 1 and 3. So we'll start iterating from the back. So we will be here first. So we need to find any element greater to the right. So what we can do? Suffix of j plus 1 will give the greatest element which we have after this jth index till the end. So this will give the maximum value which we can have to the right side. And what is the current element? Current element is ARR of j. So we need to update our suffix array by taking maximum of both of these. So whatever will be maximum, we will write it in our suffix array. So maximum of 1, and what is the greatest element that we have to the right side? That is 3. So maximum of 1, 3 is 3. So we'll write 3. Then we'll come across this 1. So maximum of 1, 3 is again 3. So we'll write 3. 2, 3 again 3. 1, 3 again 3. So this will be our suffix array. So after creating the prefix and suffix array, we need to find the triplet. So how we will find the triplet? Let me show you. So 1, 2, 1, 1, 3. So this is the our ARR array. So let me change this. So yeah, this is our ARR array, and we can observe one thing, that this element can't be our middle element of the triplet, as well as this element can't be our middle element of the triplet, because there is nothing to the right and there is nothing to the left. So we will always iterate between this range. So we'll start from here. So our current element is ARR of j. We are iterating with j. So we need to find minimum element from the right. So what we can do? Minimum element from the left, not right, minimum element from the left. So to get the minimum element from the left, we can write prefix of j minus 1. So this prefix of j minus 1 will give the minimum element from the left, and for the maximum element to the right, we can write suffix of j plus 1. So this will give the maximum element from j plus 1 till the end. So we will let's see what we can get. So we are at 2. So prefix of j minus 1 will be this 1. So 1 and 2 is the current element, and for the maximum element, suffix of j plus 1 will be 3. So yes, so we can see that 1, 2 and 3 are in increasing order. So we can return this triplet. So our answer for this test case will be 1, 2, 3, and we can return this. So this is how our algorithm is working. So what we need to do, let us summarize that. We'll create one prefix array, we'll create one suffix array, and then we'll iterate again from index number 1 till n minus 2 to get our triplet. So this is what we will do. So let us write the code now and understand in more better way. So let us write the code now. So first of all, we will declare one integer n which will store the size of the ARR array, and we'll first create the prefix and suffix array. So prefix, which will be of size n, vector of int suffix, which will be again of size n. Now we need to initialize our prefix array and suffix array. So prefix of 0 will be ARR of 0 because there is nothing towards its left, and for the suffix array, suffix of n minus 1 will be equal to ARR of n minus 1 because there is nothing towards its right. Now we will fill the prefix array and the suffix array. So first we'll fill the prefix array. So for prefix array, what we will do, how will we fill the current position in our prefix array? We need to take the minimum of current value, that is ARR of I, and whatever minimum that we have till now, that is nothing but prefix of I minus 1. So this is how we'll fill the prefix array. For the suffix array, we will iterate from n minus 2 and we'll go till 0. And what we'll do, we'll fill the suffix array in this. How we can fill the current position in the suffix array? We'll find the maximum of two values, that is the current value and whatever maximum value which we have from the index plus 1 till the end. So that is nothing but suffix of I plus 1. So this will fill our suffix array. In the end, what we need to do, we need to find the triplet. Our triplet can be always be in the range of 1 till n minus 2. So we'll iterate from 1 till n minus 2. Now what is the condition for the triplet? This is the condition for the triplet. So we will see if our current element, that is ARR of I, is greater than some like if we can find any minimum element from its left. So how we can find the minimum element from its left? Prefix of I minus 1. So if there exists any element from the left which is lesser than ARR of I, as well as if we can find any element which is greater than our ARR of I towards its right, ARR of I. So this ARR of I should be lesser than suffix of I plus 1. So this suffix of I plus 1 will give the maximum element from index number I plus 1 till the end, and this prefix of I minus 1 will give the minimum element from 0 till I minus 1. So if this condition is fulfilled, that means we found our triplet. If we found our triplet, we will return that triplet. And what is that triplet? The order will be prefix of I minus 1, comma ARR of I, comma suffix of I plus 1. And in the end, if we have not find any triplet, we will simply return an empty vector. So this is how this code will work. So let us submit if this get accepted or not. So yeah, our code got accepted successfully. So hope you learned from this video. Thank you.